What is the laser? Well, laser is acronym for light amplification by the stimulated emission of radiation. It's an optical device that generates intense beam of coherent monochromatic light by stimulated emission of radiation. So, from the name and the definition, we can figure out the properties or the characteristics of the laser and its technique. So, what are the characteristics of the laser? The laser light has 4 unique properties or characteristics that differentiate it from the normal ordinary light. So let's do comparison between them to get it in better way. That's the laser light and that's the normal light. The first one is the coherence. So the normal light is emitted when the electron inside any atom jump from high level of energy into lower level of energy. So that excited electron will give energy as photon. In ordinary light sources such as lamp, sodium lamp, and torchlight, the electron transition from one level to another level occur naturally. It occurs anytime and in different directions. And the photons emitted from ordinary light sources have different energies since they emitted randomly. So this electron, when it needs to jump to this one, it will emit a low amount of energy. But when it needs to jump to very low level, it will emit a very high amount of energy, given different wavelengths of light and different frequencies. So the ordinary light will emit like that in different wavelengths and different frequencies, meaning the ordinary light is in coherence. And those electron transitions occur naturally in different times with different wavelengths and frequency. What about the laser? Again, we have that atom with different levels of energy, and we have also the electrons. As we said, in the ordinary light or the normal light, the electron will jump to the lower level at any time. Well, not in laser. In laser, the electron transition from high level to lower level occurs in specific time, given specific amount of energy. So all of the electrons will jump to the same level of energy at a specific time. So all of those electrons will emit the same amount of energy, which means the same wavelength color and the same frequency. So we stimulate those electrons to emit that energy. But again, at a specific time. So those steps occur artificially in the laser and naturally in the ordinary light. The electrons inside the atoms of the ordinary light will jump from one level to another at different times and also in different directions, given different photons traveling in random directions. So we will have different wavelengths from those electrons. Again, they are in coherence. Well, not in laser. They travel at the same times in a specific direction. you will find the whole electrons emit the same amount of energy. So the energy emitted from this one equal to the energy here, meaning we will just have one wavelength moving in one direction only. So the source of the light will be something like that. In the ordinary light, different wavelength in different direction, spreading all around. So you will see it started as a narrow beam, then it spread in a very wide shape. Well, not in the laser side. So in laser, that will be the source of the light with just one wavelength and only one direction. From beginning to the end, the laser have the same diameter. So it will start, for example, with 2 centimeter, ends with 2 centimeter too. While in the ordinary light, it starts, for example, with 5 centimeter to spread up to 200 meter, for example. So here the light energy will not be lost easily. It can travel for a very long distance, way longer than the normal light, giving the second property of the laser, which is directionality. And the third one is the monochromatic. Meaning that light containing just a single color of wavelength. It could be in green only, it could be in red only, it could be in blue only, whatever was the color, but it's just one wavelength, making the laser monochromatic against the ordinary light, which spread in different wavelengths and different frequencies. And of course, different amount of energy, which means in laser, all the emitted photons have the same amount of energy. The last property is the high intensity of the laser. Well, you know that the intensity of wave is the energy per unit time flowing through a unit normal area. In the ordinary light source, the light spreads out in all directions, which means if you look at 100-watt lamp filament from a distance of 30 centimeters, the power entering your eyes is less than 1/1000 of watt. Well, not in laser. The light will spread in a very narrow beam and small wavelength range. It will not spread all around such as in the ordinary light, which means that 100 watts instead of all that direction will be just in this small area, giving the laser the high intensity property. So the laser here is very focused. That makes 1 watt of laser appears many thousands times more intense than 100 watts of the ordinary light. Because here it's spreading all around while it's here focused in just one area. So those were the characteristics or the properties of the laser. What about the principles of working of laser? Well, lasers photons are interacted in 3 ways with the atoms. Again, we have the atom with nucleus and different level of energy. Here we have the electron. The electron will absorb energy as photon to jump from ground level into higher level of energy. And that's the absorption of radiation. Electrons in the ground state are called lower energy electrons or ground state electrons, where the electrons in the excited state, which means they already absorbed energy to jump to a higher level, are called higher energy electrons or excited electrons. So those electrons cannot jump here unless they have the right amount or enough amount of energy. The amount of this energy equal the differences between this level and this level. This excited electron has a specific lifetime, which about 10 to minus 8 seconds only. When this lifetime of the excited electron ends, it will return again to the ground state naturally, giving energy, of course, or emitted energy. And since it's occurs naturally, we call it the spontaneous emission. Meaning the excited electron will go back again to the first ground normally, naturally, spontaneously when its lifetime ends. Therefore, we have no control over when an excited electron is going to lose energy in the form of light. That occurs in the incoherent light or the ordinary light. The electron will absorb energy at any time, and when the lifetime of that electron ends, this electron will go back again to its ground state after giving energy. This process of emitting energy in laser occurs by stimulation. So the third one is the stimulated emission. So in spontaneous emission, the electron will return back to its place or the ground state when the lifetime ends. In laser or stimulated emission, we will force that electron to return back to the ground state before the end of the lifetime. So we can control the time of this excited electron. And we can do that by incident photon. So that photon contains energy. It will interact with that excited electron to return it back to the ground state before the end of the lifetime. And when that excited electron returns back to the ground state, that will give another photon. So in stimulated emission, we have the first incident photon and the second photon emitted by the excited electron. The stimulated emission process is very fast compared to the spontaneous emission process. In this one, the spontaneous, we will have just one photon and two photons in the stimulated emission. This one occurs naturally, while the stimulated one occurs artificially. What are the components of the laser? All lasers have three primary components. Number one, the medium, or also we call it the gain medium. And we have the pump. And the third one is the resonant cavity. So we have a cylindrical tube. This cylinder tube is full with gain medium or the laser medium, and it could be gas, liquid, or solid. This to make sure we have molecules and atoms inside that cylinder. So why we need the medium or the gain medium? to make sure we have enough molecules and atoms inside that cylinder. Typically, the laser is distinguished by its medium. In natural condition, the atom has more electron in the lower level than the higher level. But in laser, we need to make sure we have more electrons here than the lower level to emit more energy. And we call that the population inversion. And in order to achieve the population inversion, we need to supply energy to the laser medium to make sure that we have more electrons here than the lower level. How can we do that? By the pump. There are three different laser pumps. The electromagnetic, which means using electricity, the optical, using light, and chemical, which use the chemical reaction, and all of them are source of energy for those atoms inside the medium. Laser resonant cavities usually have two flat or concave mirrors at each side of that cylinder. The back area is made of 100% reflective mirror, while the front mirror is partially reflected, something between 95 to 99%. So in the middle we have those atoms. That source of energy supplies sufficient amount of energy to the laser medium by which the electrons in the lower energy state are excited to the higher energy state. Then those excited electrons will return back to the ground state to give energy. This will become an excited atom, stimulate the next atom, and this one will stimulate the other. This will stimulate this one to have a high amount of stimulated electrons here. The completely reflective mirror is called high reflector, and the partially reflective mirror is the output Coupler. The light generated here inside the medium will bounce back and forward between the two mirrors. This will stimulate more electrons to release light while falling to the ground state. And this will amplify the light too. So the resonant cavity accounts for the directionality of the beam, since only those photons that bounce back and forth between the mirrors lead to amplification of the stimulated emission. The electron will bounce from here to there. The partially reflective mirror will allow some of that energy to transmit as the laser beam. So again, we have energy to stimulate more atoms, and that high energy of light will go out in one direction only with high intensity, which is the laser. What are the types of the laser? It depends on the medium inside the laser. Is it gas, solid, or liquid? And we have a fourth type with the semiconductor laser. In the solid type, such as ruby or YAG laser, the medium is glass or crystal. Both YAG and ruby laser use the light as a source of energy or the pump of energy. Ruby uses the visible light. In liquid, the medium is organic solution, and also the light will supply energy to the laser medium. And the medium in the gas laser obviously is the gas. They could be different types, such as helium, neon, or even carbon dioxide laser. The last type is the semiconductor laser. This one is very cheap, compact size, and consume low power. We also call it laser diodes. In semiconductor laser, the pump or the source of energy is the electricity. When you direct a beam of laser, the beam will look something like that, a straight line, and the shape of the laser on that media will look a fully circular light. But sometimes when you direct that laser to a rough surface, such as white paper for example, the light of the laser will be scattered. So the pattern of the light will not be regular shape, but there will be a random granular pattern around that circle because of the scatter. And this one we call it the speckle. So the phenomenon of laser speckle occurs when laser light illuminates a diffuse surface. The high coherence of the light produces a random granular effect known as the speckle. And this occurs when we have a rough surface. This technique, you can see it when we use the mouse of the computer. You will see the mouse from the bottom has a light here, and when you move the mouse against the surface, you will see the pointer here easily inside your laptop or your computer. If that surface is very smooth, the mouse cannot move. But if that surface is rough enough, the mouse will move easily using the technique of laser speckle. So that laser speckle is really sensitive to any motion. We can also use it in the imaging of the retina. The retina is the film inside your eye that is sensitive to the light. As you see, it's full of red color. When there is hemorrhage, we cannot see the retina clearly. So to increase the contrast between those vessels, the red vessels, and the background, we will use the laser technique or the speckle for imaging to give a high contrast photo of the retina. Now we can differentiate between the red vessels and the background. The laser speckle is a random phenomenon and can only be described statistically.